Today the notes are on section 14.4, graphing exponential functions. So again, all the functions that we're going to graph today are going to be of the form y equals a times b to the x. And the target, or the goal for today, is to describe the pattern of increase or decrease for an exponential function, including describing what's called the end behavior of the graph. And so we'll practice what this means in the coming examples. Question number 1 says to graph the exponential functions on a graphing calculator and then match the graph to the correct function rule. So in order to graph these on a graphing calculator, you're going to go to the y equals button on your graphing calculator, and then you'll type in each of these and the way that they look. So in the notes today, I'm going to talk about how you could do it without a calculator, but you could do it with a calculator and then you could just match them up. Remember that the number on the inside of the parentheses tells you whether it's going to be growth or decay. So I know this one's going to be growth because the 2 is larger than 1, the 2 that's inside the parentheses. So this one's going to be growth. The 2 inside the parentheses, this one's going to be growth. The 5 inside the parentheses, this one's going to be decay. And then the 2 inside the parentheses, this one's going to be growth. And the number out front is the place where it crosses the y-axis. So on this one, my y-intercept, my a value is 3. I guess it would actually be better to write that as an ordered pair. On this one, my y-intercept would be 0.5. Just kidding. 0, comma 0.5. On this one, my y-intercept, my a value is 3 again. And then on this one, my y-intercept, or my a value, is going to be -3. So that should help me figure out which one's number 4. So let's see. For the ones over here on the graph, so this one crosses in 3, it's going up. And so 1, 2, 3, and this one's going up. So this one, A, would match with Roman numeral number 1. B looks like it crosses up here at 3, but this one is coming down. And so the one that crosses at 3 but's coming down is Roman numeral number 3. 1, 2, 3. C and A kind of look alike, except C crosses the y-axis a little bit lower, and so C must be with number 2, because that one was supposed to cross at 1/2 and go up. And then D, this one over here, it crosses at -3. An interesting thing about D is that it might look like it's decay because it's going down, but the words growth and decay actually describe whether it's getting bigger or smaller more quickly. So D is a growth graph, but it's just flipped upside down, and tomorrow we'll practice how the negative out front on number 4 flips this function upside down. So we'll get to practice that. Remember though, to answer this question, it just wanted us to type them into the calculator, into that y equals button, and practice graphing them to see how they change. So we can also get the answers to the question that way as well. Alright, so question number 2 gives us a function. It's y equals 3 times 4 raised up to the x exponent. From our notes yesterday, we know that the 3 means that my a value is 3. That also means that my y-intercept is going to be the point 0, 3. My b value is the number inside the parentheses. So this one, that number is 4, and when this number is bigger than 1, it means that it's an example of exponential growth. So this one should be increasing or getting bigger. To get the numbers in the table, I'm going to take the function and I'm going to plug in the domain, and then I'll take the function and plug in the domain value that I'm trying to evaluate the function at. So on all of these, I'm just plugging the numbers -1, 0, 1, and 2 in. Notice that the domain wasn't given to me in the list format, so when I'm done graphing this one, I am going to draw the curve that goes through these points because this is a continuous function. The -1 flips the 4 down into the bottom, so that's 3/4. Anything raised up to the power of 0 equals 1, so this part's going to turn into a 1, so 0 goes with 3. Do PEMDAS on these ones, be careful. 4 to the first is 4, 4 times 3 is 12. And then on this one, make sure you square the 4 first. 4 squared is 16, and 16 times 3 is 48. So that means that -1 goes with 3/4. And it means that 0 goes with 3. And this one means that 1 goes with 12, and then 2 goes with 48. And it's okay if the 48 feels kind of big. Remember, these are exponential functions, so they are supposed to be getting bigger very quickly. Alright, this isn't easy. When you draw the curve through it, you just do your best. And I'm doing this in pen, so I make no promises, but... well, it's been worse. Okay, I can still see my 4 points very clearly that I graphed on the graph. And I tried to draw as smooth of a curve as I could, and I put the arrows on both ends to indicate that it keeps going. We already said that we knew that the y-intercept was the point 0, 3. The y-intercept is always going to match the a value. So my a was 3. That's how I knew that that was my starting value, and that's how that I saw that that was the y-intercept. End behavior is a little bit trickier to describe. So when I show end behavior, this is one way that you can think about it. You're going to put a positive infinity up at the top, and then 0 in the middle, and a negative infinity down at the bottom, and then you'll do the same thing on the other side. Positive infinity, 0, negative infinity. I want to make sure that I point out that sometimes the positive infinity doesn't have the positive sign in front. So I'm writing down the positive sign out front is not necessary to put the positive sign, but sometimes on HRW they do put the positive sign out front, so I wanted to make sure that you had seen one where it was like that. So, let's see. It says, as x approaches positive infinity, y approaches blank, and as x approaches negative infinity, y approaches blank. As x approaches positive infinity means as the graph goes further and further to the right, and as x approaches negative infinity means as the graph goes further and further to the left. So for the first one, as x goes to the right, this graph is going up. It's getting closer and closer to positive infinity. So when you write it over here, you can write it just as the infinity symbol, but like I said, sometimes they're going to look for the plus sign out front. So positive infinity and regular infinity are the same thing. As the graph goes to the left, the graph isn't getting taller and it's not getting smaller. It's getting closer, well, it is getting smaller, but it's going closer and closer and closer to 0. So as the graph goes to the left, as x approaches negative infinity, y approaches 0. Don't worry about summarizing these and writing down what the rules are for them. What I want you to practice is being able to make a table, plug the numbers in, get the numbers out, plot those ordered pairs, and then answer these questions about the graph, especially the ones that ask you about end behavior. That's something that Question number 2 follows a similar pattern. In fact, it looks a lot like question number 1 did, but what's different is this negative out front. So it's going to be negative 3 times 4 to the x power. So I'll follow the same pattern for this one. I'll do negative 3 times 4 to the negative 1, to the 0, to the positive 1, and to the positive 2. And so I'll get values out for each of these. When I go through and do the math with this one, remember the negative exponent flips the 4 down into the bottom. So this one's going to give me negative 3/4. This one will give me negative 3. This one will give me negative 12 and negative 48. And you can confirm those with a calculator as well. And so that's going to allow me to determine where to put the points on the graph. So negative 1 goes with negative 3/4. 0 goes with negative 3. 1 goes with negative 12. And 2 goes with negative 48. And so let's try to connect those in a smooth curve. There we go. And so the a value, remember that's always the number out front, and it's always going to be your y-intercept. So I already know that my y-intercept is going to be the 0, negative 3. The b value is the number inside parentheses, and so that's a 4. On this one, it's a multiplier, and so that means that this graph is growing. It's exponential growth. Kind of tricky. It's exponential growth, even though it's going down. Kind of strange. Growth just means it's getting, moving away from 0 more quickly. That's the definition of growth. And we'll practice that more in the notes coming up next week. Remember, for end behavior for this one, you've got positive infinity, 0, and negative infinity, and then you've got positive infinity, 0, and negative infinity. And so as x approaches positive infinity, that means as the graph goes to the right, and then as x approaches infinity, that means as the graph goes to the left. Because remember, your x-axis is the one that goes this way. So as x gets bigger and bigger and bigger and bigger, the graph is getting closer to negative infinity. It's going down. As the graph goes to the left, so as x gets smaller and smaller and smaller, it's getting closer to 0. And again, don't worry about filling in the summary for this one. When you describe the end behavior of a graph, you're just saying what happens as the graph keeps going. For question number 3, I'm given a different exponential function with different numbers, but to evaluate it, I'm going to do the same thing. So I'll plug in the -1, I'll plug in the 0, and the 1, and the 2. And so you're going to evaluate this by plugging these expressions into a calculator. It would be helpful to grab a calculator for this one so that you have the numbers to divide it in. When I type this one in, the 0.4 moves down into the bottom, and so I get out 5. Anything raised up to the power of 0 equals 1, so this one's going to give me a 2. When I do 2 times 0.4, that gives me 0.8. And then for this one, I get 0.32. So -1 goes with +5, 0 goes with +2, 0.8 is a little bit less than 1, and then 0.32 is a little bit less than 1/2. And so for this one, here's my smooth curve. My a value is the number out in front of the parentheses, so my a value on this one is 2. That means that I also know that my y-intercept is the point 0, +2, that's where it crosses the y-axis. My b is a number inside the parentheses, and so for this one, it's 0.4. 0.4 is a number in between 0 and 1, and so just as a heads up, decay means the graph is getting smaller more slowly, and so decay means it's going to get closer and closer and closer to 0 as the graph goes on. Let's see, so for end behavior for this one, we'll do positive infinity, 0, negative infinity, and then positive infinity, 0, and negative infinity. So as x approaches positive infinity, that means as the graph goes to the right, and then as x approaches negative infinity, means as the graph goes to the left. I really like to use my pencil when I'm doing end behavior. I haven't said that yet today. So as x goes to the right, the graph's getting closer and closer and closer to 0. And as x goes to the left, the graph's going closer and closer and closer to positive infinity. And just remember, you might not need that positive sign out in front of your infinity when you type it into the HRW homework tonight online.